Welcome back to this video. Welcome back to Science Modernizers. So today we are going to solve a problem on calculus, that's on integration. Okay, so the question is displayed on the screen. Now the question says, given that L is equal to the integral from 0 to pi on 2 of cos to the 4x sine squared x dx, and M is equal to the integral from 0 to pi on 2 of sine to the power 4x cos square x dx. Find L minus M and L plus M, hence deduce L and M. Okay, so let's get started. So we are going to split it into two. So Roman 1, let's find L minus M. Let's see what it gives. Now you realize that our integrals have the same boundaries, so it means we can just subtract them. So I'm going to let the big integral L minus M to be equal to the integral from 0 to pi on 2 of L minus M. So my L is cos to the 4x sine square x, then we have minus M, that's minus sine to the 4x cos squared x, all of this dx. So what do we get? It means L minus M will be equal to the integral from 0 to pi on 2 of, so we clearly see that here we have cos squared is common, sine squared is common. So I'm going to factor out cos squared sine squared. So I'm going to have cos squared x sine squared x factored out. What will be left? Here will be cos squared x minus sine squared x dx. Now we are going to change variables. So changing variables mean, or let's simplify this first. So cos squared x, but we know that cos squared x from Pythagorean identities minus sine squared x, this gives us cos 2x from double angle identities, and so this means that L minus M will be equal to the integral from 0 to pi on 2 of cos x sine x, all of this squared, then times cos 2x dx. Now with this, I'm going to create a function here, so I can multiply here by 2 and divide by 2, but all of those are in a bracket. So what do we have? We now realize that 2 sine x cos x, or 2 cos x sine x, is an identity that we know, which is sine 2x. So we recall that sine 2x is 2 cos x sine x. So it means I can replace it there. So this means that my L minus M will be the integral from 0 to pi on 2 of, what do we have? That will be sine squared 2x divided by 4, then times the cosine of 2x dx. So it means that L minus M will be the integral from 0 to pi on 4 of, I'll keep this outside, 1/4 of sine squared 2x cos 2x dx. So now let's change variables and solve that integral. So changing variables, I can let my u to be equal to sine 2x. So this means that my du will be equal to 2 cos 2x dx. But if I divide all through by 2, we see that my du on 2 will be equal to cos 2x dx. So I will replace in my integral. So this means that L minus M will be equal to the integral. I'll keep my boundaries aside. My u has now become sine x, so it's going to be u square. Then cos 2x dx has become du divided by 2. Now let us not forget our 1/4 outside times that integral. Now this means L minus M will be 1/8 times the integral of u square du. And so what does this give? This gives 1/8 u to the power 3 divided by 3. But our u was cos 2x, so here we have cos 2x. Yes, our u was sine 2x rather. Our u is sine 2x. So it will be sine 2x divided by 3, sine cube 2x divided by 3. So we are taking it from 0 to pi on 2. Now multiples of n pi will always be 0. So sine 2 times pi on 2, that will be sine pi cube. Sine pi is 0, so cube is 0, and sine 0 is 0. So it means L minus M will give us 0. Now let's verify L plus M. L plus M will simply be the same procedure, the integral from 0 to pi on 2 of what we saw. Will be exactly this. It will be exactly this, but what will change is simply the sign. So it's going to be cos to the 4 sine square x plus sine to the power 4x cos square x dx. So this will be the integral from 0 to pi on 2 of cos square x sine square x. All of this factor of what will be left is cos squared x plus sine squared x dx. But this from the Pythagorean first identity is equal to 1. So it means that we'll just have the integral from 0 to pi on 2 of the same thing, cos square x sine square x. We saw that it is sine squared 2x divided by 4 dx. So from there we can now use the double angle identity, from where we know that cos 2x is equal to 1 minus 2 sine squared x. So this means that cos 4x will be equal to 1 minus 2 sine square 2x. And so this means that my sine squared 2x will be equal to 1 minus cos 4x, all of this on 2. So this means that my integral L plus M will be equal to the integral from 0 to pi on 2 of, I'll keep 1/4 outside. Let's keep that 1/4 outside. So that will be 1/4 times the integral from 0 to pi on 2 of 1 minus cos 4x, all of this on 2. Now that 1/4 will multiply by 2. It means L plus M is equal to 1/8 times the integral of 1 minus cos 4x dx, and I'm taking it from 0 to pi on 2. So what do we have? It means that my L plus M will be equal to 1/8 into, when you integrate 1 with respect to x, it gives x, and when we integrate negative cos x, we have negative 1/4 sine 4x from 0 to pi on 2. Now the upper limit, we have L plus M will be equal to 1 divided by 8 factor of pi on 2. Now, but if I replace pi on 2 here, that will give us sine 2 pi, and sine 2 pi is 0, and lower limit will still be 0. So what does it mean? It means that my L plus M is equal to pi divided by 16 units. But remember, the question was we should deduce L and M. So the value of L plus M is pi on 16, and the value of L minus M is 0. Now let's deduce L and M. Now we have that L plus M is equal to pi on 16. So that's equation 1, and L minus M is equal to 0. So if we sum these two equations, number 2, if we sum the two equations, what we have is we have 2L is equal to pi on 16. So this means my L will be equal to pi divided by 32. Now from equation 2, L is equal to M. So this means M is equal to pi on 32. And that brings us to the end of this video. Thank you for watching, and see you in the next video.